before you're working on any kind of battery or battery setup, anything with power even, wear safety glasses at minimum, earplugs, as you will see right here, or get a face shield, because you'll need it in case something does happen. I will reference it throughout the video. Let's continue. Hey guys, welcome back to the channel. We're going to do a series hookup for all these batteries. To get the materials to do this, because I don't want to just waste connectors, I'm just going to grab a bunch of these cables. They have the cat's eyes, was what I call them, at the very end. So we'll dismantle all the stuff for the chargers. This is an inverter, as you can see down here. You've seen it before. And we'll reuse these wires to do the series connection, so you get a demonstration of what a series batteries would look like. Even though these batteries are not good, I did map out what they all are over the 48 hours of testing them. And even now, with this battery here, I'll just quickly put the connectors on it. There we go. It was 1310, now it's 1308, so it's not holding a charge, but it's still holding a lot better than the other ones across here. These ones are always over boiling, because when you can't charge a battery, or a battery will not take its charge, it will create heat, and to create heat, the water inside these things, which I'll open one up just now, as you'll see a little bit of a flash there, like as in like a little bit of glare, it'll boil off, and or if it does not able to boil off, it could explode, which is not good for anybody. Again, over here, we'll just put these terminals on. I just mix them up. Might think I'm colorblind. I don't know. And there we go. So this was 1303, and now it's 13 flat. Battery's not flat, just 13 flat. Anyways, we're gonna hook these up in series so you can see a demonstration of that. Yes, I know I shouldn't be doing this, but I'm gonna do it anyways. Only because the batteries are at different levels, because then they will try to start filling each other up, and it could create heat, but it's not gonna be there for long. So again, it's okay. So I'll give you a quick, simple diagram of a series. We're gonna have our 4 batteries, and right about now, I'm gonna hit time lapse. So what we have here, guys, in series is 5 batteries, so 12-volt batteries equals 5 times 12 is 60 volts. These are all 10 amp hour batteries, so we still have 10 amps hours, and that's because it's at 60 volts for 10 amp hours. Here I'm just dismantling the chargers to get the wires so we can start setting up the batteries in series. So we've completed the circuit. It's all loose. I don't know how effective it's going to be, but we should have around 51 volts coming from the series array. And it's gotten over the 20, so that's a good sign. We have 43.6 volts, so I'll try to keep that in place. There we go, 45.6. As you see here. So all these batteries are not good, as you can see. 6, oh yeah, I typed in that wrong. 11, 13, which is decent. 2, and then 13, which is good. So these 2 are decent and good. But yeah, that's our new rating, and you can see how it's fluctuating. So that could be from bad connections, and it could be from these 2 batteries charging these other 2, sorry, these other 3. But yeah, so this is a series of batteries connected together. Next, we'll do a parallel with only 4 batteries. Now we remove all the terminals and connections. Now that the batteries are all set up, I figured this would be a good time to interject a wiring diagram. So we have all the batteries in parallel, and we just add the last 2 wires to combine those 2 pairs into 1 pair. So all batteries will be connected together in parallel. Now to take these 4 batteries and to wire them into a parallel circuit. So I took 2 batteries on either side, wired them together. So positives, positives, negatives, negatives. And here we have a balanced battery array. All the wires are pretty close to the same length because they're from all the same chargers as was taken up here. And we started by putting these 2 in parallel and putting these 2 in parallel, and then adding the jumpers from one side to the other, and we get our 12.5 average between the batteries. So this is at 13, that one's at 7-ish, this one's at 11, and that one's at 13 approximately. It gives us a 12.5. That was originally at 12.7, so it's actually gone down 2 points. And we are at a parallel battery array that gives us a total voltage over the highs and lows of 12.5 now. And if I say wait around, these things will kind of level themselves off, which is the natural state of batteries. If you have a BMS system, it'll be a better battery management system. And that's that. Now, if you have a new battery system, you don't really need a BMS system. It's only for older batteries, because each battery wears out at a different place, because they either have longer or shorter wires closer to the end of the circuit or closer to the beginning of the circuit. It all plays a role, whether they're on the top of the shelf or the bottom of the shelf, and if they're exposed to hot and cold frequently. It all plays a role. Anyways, moving your batteries around will increase the life expectancy that you have for the use of them. Now to do the series plus parallel diagram. So the parallel plus series works like two sides are parallel, and then you add one wire in between to create the series for the double the voltage. Here I'm removing all the wires to start from scratch. So now nothing is hooked up. We'll do the parallel version of this first. So these two will be in parallel, and these two will be in parallel. So now we have two pairs of batteries in parallel. Nothing's cinched down, but we'll get 12.6, and then we'll get 12.4 between the two batteries. Next, we're going to put it in series to get 24 volts. Now that everything's hooked up, these two are in parallel, these two are in parallel, and then these two pairs are in series. So we have our negative right here, our positive right here, and the wire that's connecting them two together. So positive on this side of the circuit goes all the way around, connects these two together, then transfers over to the negative on this circuit, and then comes over to where the negative is on this side of the circuit and follows through. So we should theoretically get around 24 volts. Okay, I had to play around with it a little bit. These connections are all loose because I want to take it all apart shortly. And we get, if I put it from here to here, so I'm just doing the battery, 12.4. And if I go from here to here, we'll get the series voltage, which is 25.3. If I go from here to here, we get the parallel voltage, which is 12.5 between the two. And there you go. That is your definition of a series to parallel battery setup. So thanks for watching, guys. If you have any questions, comments, concerns, please leave them down below and I'll get back to you guys as soon as I can. And as always, stay safe, have fun, and if you're doing anything questionable, name it after me. Peace!